So right here's a website where I can sample from a population. There's what this is showing right here is a population of 18,000 people, and here we see each person's ID number, and here we see each person's sleep time. It's just the number of hours that each person sleeps per night, and it lets me take a sample size and then take a sample of a random sample from that population and then collect data from the sample. So imagine that I want a sample size of 10. It can actually draw 10 people and collect their sleep times as if I had actually done a survey with those 10 people, and then calculates the mean or the average of the sample by adding their 10 numbers and dividing the total by 10. So here we can see that the population is normal or bell-shaped with a mean or average sleep time of 8 hours. So the mean of the entire population is 8 hours, and these are the 10 people in the sample, and this is the mean of that sample. If I click on Draw Samples again, it'll take another sample of 10 people and record their sleep times. So it's as if I have done the study over again, or someone else has repeated my study with a different group of 10 people. It shows the 10 people inside of a population. It shows the 10 people right here and the mean of the sample. So and it can repeat this process over and over again. And eventually these will start to form a normal distribution, because if the population is normal, then the sample means end up forming a normal distribution. Also, the sample means are closer together than the individual people are, because notice how the sample means are all between, most of them are all between 7 and maybe 9, but the individual people are all between 5 and 12. So the sample means are always closer together than the individual people are, and that's especially true if the sample size is large. With a large sample size, the sample means are even closer together. So they're closer together than the population values are, and but they do follow a roughly normal distribution, just like the population does. Remember that the population is normal, the sample means always have a normal shape. So let's try to take samples of 30. So what this does is it randomly selects a sample of 30, calculates the mean of the sample, and plots the sample mean right here. So here's the 30 people inside of my newest sample, inside of the population. Here's their sample mean of 7.5, and their sample mean right here. Notice how most of them come from the lower end of the population. So they have most of them have lower sleep times. That's why that's why the sample has a lower sample mean down here that actually falls below the population mean of 8 hours. So here I have a sample with a sample mean that underestimates the population mean, because the sample mean is lower than the population mean. The sample mean is 7.5, the population mean is 8. And every once in a while, sometimes I'll get a sample mean that's above the population mean. For example, this group of people here had 30 people toward the high end of the population, with a lot of people who were getting more sleep, which is why their sample mean ended up being a higher number up here. So since the sample included a lot more well-rested people, their sample mean ended up being a high number up here, above the population mean. But it's still going to build up to form, the sample means will still end up forming a normal distribution because the population is normal. And if I did this with if I calculated the means of all possible samples of 30 and recorded each of those sample means as a building block in here, then that would actually be the complete sampling distribution for all possible samples of 30. But if the population is skewed, well, in that case, with if I'm taking a small sample of, let's say, 10 people, um, I'm likely to get a low sample mean because I'm likely to get a lot of people from this lower end because there's a lot of people to draw from down here and not as many people up here. So a lot of the sample means will end up being low. And the sample means will end up forming a skewed shape just like the population. You'll eventually see it, but not quite yet. I can actually do this it'll actually let me calculate the mean of a large number of samples all at once. So I could do 1,000 samples all at once. It's just taking a second, it'll come up. So the shape still ends up having a positive skewness, just like the population. It's maybe not quite as skewed, but it's still following that positive skewness. Now, and what I can do here is the website actually lets me click on each sample mean inside of here, and it actually shows me the 10 people that are in that sample. So this building block is the mean of these 10. This building block is the mean of these 10. This is the mean of these 10. And if this was showing the means of all possible samples of 10 here, then that would be the complete sampling distribution of the means of all possible samples of 10 people in this population. Now, if I select samples of 30, a bigger sample size, the sampling distribution will be normal, or at least roughly normal, even though the population is skewed. So these sample means will eventually start to form a normal shape. Because if you look at these possible samples of 30 that we're looking at here, a lot of these samples do include a lot of people from the lower end here. There's also, since there's a bigger sample size, there's more higher people mixed in, like there is here, which brings up the sample mean. If each of the possible, so since these possible samples of 30 tend to include higher sleep times mixed in to them, all of those possible sample means aren't quite as low as they were before. That's why they're starting to form a normal distribution. So here we can revisit the samples. We can see that a lot of them have at least some higher people mixed in who bring up the average, which is why the sample means aren't quite so skewed down here as they were before. So now I'll actually move on to the PowerPoint slideshow. This was just meant to demonstrate the idea of the central limit theorem about how the shape of the sampling distribution depends on the sample size and the shape of the population.